It's a pleasure having you again, my friends, here on Will EduTech. And in the previous exercise, we looked at part 5 in our activities on exponents and indices. So in this lesson, we'll be looking at question 13. And it states here, 16 upon 81, all raised to the negative 3 upon 4. Okay, so here we have a negative exponent. So if you should recap, or if you should remember when we were looking at the properties of a negative exponent, we said that simply, and we looked at the whole concept behind this. So if you're not sure, you could always revisit that video. Now, we said that when a base is raised to a negative exponent, simple, you can just flip the fraction. In this case, it's a fraction. You can just flip the base, okay, and the power will become positive. So instead of having 16 upon 81, we're going to have 81 upon 16. Okay, and now my power, if you notice now, my friends, my power will become a positive 3 upon 4. Okay, now simply, my friends, what this is saying, another way of looking at this, or an easy way of looking at this, I can look at the base, I can look at my numerator and say, what is the lowest base my numerator, which is 81, can be written to? Well, we know that 3 times 3, and let's just work it out here, 3 times 3 times 3 times 3, this is 3 3s 9, 9 3s 27, and 27 times 3, that will give us a 81. Okay, now since we have a common base 3 multiplying itself, then I can just simply write my base 3 also and count the 3's, 1 2 3 4, so that's 3 to the 4th power. So simply, my friends, 81 is the same as 3 to the 4th. So what I can do in my numerator, I can say simply, this is 81 is the same as 3 to the 4th power. Okay, likewise, and this is all upon, and I can do the same thing for 16. I can ask myself, what is the lowest base can 16 be written to? Well, we would have already learned from earlier lessons, and if you're not sure, you could always revisit those lessons in this playlist on exponents. Now we know that 2 times 2 times 2 times 2 is the same as 2 2's will give me a 4, 4 2's that will give me a 8, and 8 2's will give me a 16. So 16 can also be written as, since I have a common base 2, I can rewrite my base 2 and I can just count the 2's, 1 2 3 4. And that's 4 up top. Okay, so I can write my 16 in my denominator as 2 to the 4th power. Okay, but we must all remember now that all of this was raised to the positive 3 upon 4. So I can just simply go ahead now, my friends, and just raise that to the positive 3 upon 4. Now simply, we can let's just take it up top here. Let's just take it up top. Let's just split the screen there and take it up top. Okay, now this implies, my friends, and I'm coming from down the bottom, if you notice, we have the power to power rule coming out here now. Okay, and that's another property of exponents. So I can simply say 3 to the 4th, okay, and I'm simply going to multiply my powers times 3 upon 4. Okay, and that's the power to power rule, and that is all over, that's all over, my friends. I can simply say that in my denominator now I have 2 to the 4th, okay, and I have to multiply that by my power also, times 3 upon 4. Okay, so by simplifying my powers, I will get 4 into itself goes once, 4 into that 4 goes once. Okay, and also here 4 into itself goes once, and 4 into 4 goes once also. Okay, so this implies, my friends, that up top I have a base 3 there, and 3, and in my power, let's look, I have a 1 here and a 3, so let's just multiply that. 1 times 3, that's 3, and that is all over, and I have a 2 in my base there. Okay, and I have a 1 times 3 also, which is 3. Okay, so I have 3 to the 3, and that can be simplified. That can be simplified, my friends. 3 to the 3 is the same. Well, let's do it over here, since we are running out a bit of space down at the bottom. We can simply say 3 to the 3rd power is saying 3 times 3 times 3. Okay, and that's all over. 2 to the 3rd power is also saying 2 times 2 times 2 times 2. Okay, so really what we have left here, we have 3 3's 9, 9 3's 27. So we have a 27 there, and also in our numerator we have 2 2's 4, and 4 2's will give us a 8. Okay, so we really have 27 over 8, and that's our answer. It is as simple as that, my friends. Hope that was useful. But before we go, let's look at another quick example. Okay, and this is question 14. Okay, 14. Let's say in an exam they gave you to evaluate 1 upon 6 raised to the negative 2. Okay, now a easy way of looking at this, my friends, we could say this is the same as saying 1 is being divided by 6 raised to the negative 2. Now, if you notice here, we have a base 6, okay? So simple, my friends. I can just simply put my base 6 over 1, and I can just simply flip that. Now, okay, based on the inverse rule. So really, this is saying 1 is being divided by, and when I flip this, the power will become positive. So I'm going to simply say 1 upon 6 raised to the positive 2. Okay? Well, let's just expand this, my friends. This is the same as saying this is 1 is being divided by 1 upon, and we know that 6 raised to the power of 2, that's like multiplying 6 2 times, and we're saying 6 times 6, which is 636. So that's simply 1 upon 36. So let's take it over here a bit. Let's take it over that side. So really, my friends, what we have here, we have a 1 is being divided by 1 upon 36. So simply, when dividing fractions, we can just simply turn the 1 into a fraction. So the number at the front will remain the same. So I'll have a 1 at the front. Then I will change my division sign to multiplication, because when dividing fractions, it is the same as multiplying by the reciprocal. So I'm just going to flip the 36 by saying this is 36 upon 1. Now, when this is multiplied out, my friends, this implies that 1 times 36 is 36. Okay, so this would be our answer. 36 would be our answer in that case. Hope that these lessons were useful. See you in the next video. We'll be looking at indices equations. Bye bye.